My name is Alex Thissen. I'm from the Netherlands, a bit further to the south, so reasonably close to Amsterdam. But in the Netherlands, everything is close together. A 3-hour drive will take you from the top to the bottom. So welcome for this session on serverless compute and Azure Functions. I'm wondering who has had some experiences or experimented a bit with Azure Functions. Okay, a couple of people. So we'll go through those the things that it takes from building serverless architectures. We'll briefly touch on that to get you up to speed on that, and then I'll introduce the Azure Functions. And I'll be brief on the part that you might have seen before, but we'll look at how to program them using .NET and C# in Visual Studio. So it's a different approach than you might have seen. We'll also cover debugging and testing and going into production a bit. It's only 40 minutes, so I'll try to keep the speed up and do a lot of things. So serverless architectures and how it relates to Azure Functions. Briefly touching on that. We've seen just a couple of trends in the industry right now. So the containerization is one of them, and it's booming. The other one is going serverless. So without servers, some might think, but you can't really do anything without any servers. So going to serverless means that you will have no servers when you don't need them. And this is about cost and pricing, because if you run container clusters and big container clusters, it will actually cost you a lot of money if they're doing nothing. And the idea behind serverless compute is that the compute goes away, at least your costs go away, if you are not using any compute. So during low times, there will be less capacity. If there's no things being done at all, everything will go away. So it's still there, but it's just you have to think about servers less. That's the joke they make. So there will be servers only if you need them. And there's a couple of things. There's also this, in the combination with containers, they are looking at serverless, where the cluster is actually scaling up and down, which is a new thing. They're working on it. If you're into Azure and the Microsoft stack, you could look at Azure container instances combined with the new clusters that they have, AKS, for example. So they do the container instances. But functions is a different thing. And the idea behind functions is that you start programming your logic, the things that need to be done, you make them very small, very isolated, almost like microservices or maybe even nanoservices, very small pieces of compute, and you build them in functions that get triggered by things that happen. So that's a new kind of idea. It's borders to the event-driven architectures, where things happening in your landscape will trigger things being done. That's good because things only will be handled when they occur. So one of the cost models that they have here is that you pay by the nanosecond or the millisecond of compute that you're actually using. So it could be as low as a couple of dollars or euros for the compute that you use in a month. Though the major cloud providers are working on offering something in the space of serverless, and they all have this form of functions. It's called differently. Amazon has the Lambda for quite a while now. Google has its cloud functions. Azure has Azure Functions, and we'll talk about that. And there's other competitors coming now that you might also look into. And they all have their own programming style, their own programming models. But we're looking at the way Azure Functions does this. And their idea is that you have the code, you have the events, and that combined will be the programming model for functions. There's a lot of architecture examples to be thought of. Some things that regularly occur is that you need to do things time-based. So if you have these batch jobs that need to run at night, there's multiple ways of implementing them. But if it's like this massive compute that comes up all of a sudden at the middle of the night because invoices have to be calculated, that would fit well with this architectural for event-driven and functions. Another one could be that you hook into the Microsoft Graph and you start reacting to all the things that happen around the Office 365 space. Files being uploaded or things happening there. Webhooks being called. For example, you could create a function that has a webhook to GitHub, so it starts doing things as soon as there's a check-in on GitHub. And another popular one is that you have this, let's say you have this website where you can do some auctioning of your own stuff. You upload a picture from your phone. One function handles storing the photograph, and the other one that triggers by it being stored in blob storage is actually doing scaled versions of it. And this is one very important thing, that you will design your architecture to work well with Azure Functions. Because if you would do everything in a single big function, that would not scale really well. Just a brief example, imagine that you have to do process 1 million of records in a database. You could do a time trigger that triggers and starts processing 1 million records. But that would probably take a long time to process. But what you could also do is make it like a rocket with 2 stages on it. First stage, get a function that will actually divide smaller tasks of chunks of records to be processed. And a second function will take the smaller chunks. And that one will start scaling probably, because there's all of a sudden, you could put the task into a queue, where it's picked up. And the underlying infrastructure from Azure Functions will actually detect that there's a lot of messages entering, because we're dividing 1 million records in all these chunks of 1,000. So all of a sudden 1,000 messages, it starts scaling, and the second function will start processing. So it will probably take a lot less time. So let's do a bit of 101, and I do know that we're all technical here, so but just to emphasize, there's actually 2 programming models in Azure Functions. One is more the script side of things, where all the new languages are in, Bash and PHP, for example, JavaScript. And that is where you can actually put things in repositories, and repositories will cause a deployment, and that's how you can work with it. The other side is what we are going to cover. It's .NET with C#, where you will use Visual Studio. And you can do all the tooling that you have. You can do pipelines for continuous integration and delivery, do all your quality checks, unit testing, and be very sure about the type and state of code that you're checking in, and your pipeline will release it into Azure. So it's the programming model and the way of working that I think you're probably familiar with. Who's more on the script side of things? Only 2, 3 hands. Okay, so we're in a good company here. So, already mentioned some of the languages that are there, so quite a number of them. Some of them are called experimental languages. If you look at the UI in Azure, C#, F#, and Visual Basic are the prime languages, but they're more on the right side, so the Visual Studio side of things. It's all open source, so if you want to look and contribute and do pull requests, you can certainly do so. And currently there's support for 2 platforms in .NET, if you take that route. It's framework 4.6.1 and onwards, and also is still in preview, .NET Core 2.0. But it will probably shift to Core 2.0 in the near future, but I'll have demos on 4.6.1, and if we have time left, I can show you the implementation in Core 2.0, but they're almost identical. So, if you look at the documentation and you talk to the teams, that are building with Azure Functions, you can see that's actually all built on top of Azure Web Jobs. And they refer to Azure Functions as just another programming model. So you have the Web Jobs core with all the programming model that exists there, and you have the extensions. Well, the extensions is one that's particularly interesting, because whenever they build extensions, and extensions is about triggers and bindings, so what can you react to and what can you use in your function, as in queues, blob storage, those kind of things, maybe Cosmos DB, that's all in that area. But if new extensions are built for web jobs, we can actually leverage them via the scripts runtime, the language layer that is on top of it, and that's where we'll do our programming and create our code and configuration. So if there's new advancements in the web jobs, we immediately can take benefit of that. But if you look inside of an Azure function, I think it's always good to know what it's running on. You'll find that it's an Azure App Service. So it could be a web application that would be running there, and it has all the things underneath that you can always also find if you deploy a web application to Azure. It has some JSON-based configuration about the hosting. If you're developing locally, you'll have a local settings file that represents the settings as they are in Azure. But inside of that running application service, you'll have one or more functions which are all of them triggered. So there's something happening, and they'll take input and produce some output optionally. So the input and output are optional. I will get back to that in a bit. Let's have a quick show at what it looks like in the portal. So I have here already prepared a new resource. I did a function app, named it .NET Framework Days, created a single function. But if you would create functions, there's actually a UI there to create additional functions. You see the switch here. Let me zoom in a bit. That says experimental language support. If you enable that, you'll get all the Bash and the the JavaScript stuff as well. But this is where you can just create your functions. And if it's there, you'll get this UI, you'll get this code. It's a C#X file, so C is X file, which is just a fragment of C#, and you can edit this locally, store it, save it, and also run it. So this function is triggered by an HTTP call. We can just try and run it, do an hello world. And if I just scale down a bit, it might just fit the window here. But down at the bottom, you'll see that you actually have your output and you have your input. So it's some rudimentary things to test your application. Okay, so there we go. There's a lot of extra things that you can find here, and I won't go into details here, but if you look underneath the covers, then it has application settings. It has, so this is where you would rev up your all your details about your connections. Has some platform features, and this is where you can see that it's under the covers. It's actually an app service. So you even have your tooling like Kudu, where you can just get down to almost the machine level and see what is running there. So you can have debug consoles, even process explorers. And if you take a look at the process explorer, it will pop up in a moment with the W3WP worker process that is running there and doing all the heavy lifting. So this is what's happening underneath. Okay, so how would you develop your Azure Functions in .NET? Because the programming model we just saw, where you have the script bit in C# and you can just edit it, save it, it kind of works for experimentation, but I wouldn't want to run my production web applications and functions that way. I'm not sure if you're adventurous like that, but if you're, I mean, it does work in some scenarios. For more enterprisey or scenarios, you might want to take this route. So first off, you need some tooling. You'll need Visual Studio 2017. Make sure you have the Azure workload installed as well. You need the tools for Azure Functions, and you need the function core tools, which has some command line interfaces as well. If you want to try the .NET Core 2 preview, you need to install the .NET Core SDK as well. And then you'll get, if you do the tooling and all, you'll get this changes quite a bit over time, but this is the current state. You'll get this dialog if you create an Azure Function project that has a drop-down highlighting if you want to do the .NET Core thing or the .NET Framework 4.6.1, and you can pick a couple of template function files. But there's actually a longer list that you can do, and they differ over .NET Framework and .NET Core. So the .NET Core list is still a bit shorter, as they're still revving up, getting to feature complete. The command line interface allows you to do everything from a command line, because you could, with .NET Core, also implement your functions not on a Windows machine and without Visual Studio. So it's not required. For now, it is with functions not being on .NET Core 2.0 officially yet. Another thing I would recommend is the Azure Storage Explorer, because a lot of the functions that you will use will actually leverage blob storage, queues, so things that you want to interact easily, and the tooling is good to make that easier. And then there's other tools like Postman, SOAP UI, something that you can do if you want to do the HTTP-based calls into your application and your functions. So back to the function app again with a function. This is where we get to the programming part. So there's always a trigger before a function happens. Could be timer based, could be something arriving in a queue, service bus, what have you. A trigger also provides input, because a message in a queue as a trigger, the message itself is obviously input. So you'll bind to that input. You need to get the message from the queue. That we will see will refer to, because we're talking functions, it will be the input parameters of a function. The output bindings, on the other hand, is what you produce. And they can, you can have a return value, obviously, but if you have multiple things that you want to output, then you would need to resort to more parameters of your function. And the thing is that, the peculiar thing is that output might be putting something into blob storage, for example, or sending out an SMS, a text message for your phone, or maybe just a simple email. That's all considered output, but it's bound to your function. So there's actually a high level of abstraction of how to deal with those types of bindings. So I think it's ideal, because with functions you really don't have to know how to read a message from the queue, because it's taken care of for you. This is how the things work. So the difference between the code fragment we just saw in the Azure portal and when you start programming in C# inside of Visual Studio is that you will do a lot of attributes. So you can see some attributes here for function name, for example. That is metadata that indicates what this function should be called. By default, it's a static method that is called run, and that's the plumbing underneath takes care of finding that function and executing it. But the registration, the way it appears in the portal and the way you can refer to it is actually determined by that attribute. Then there's the things that are input or triggers. Those are marked as attributes indicating that this is the parameter that represents the trigger. So in this case, it's an incoming HTTP request message, but it's already there. So you have the message at hand. It's called RQ, and at the bottom line in the return, you can see that you can just create output with it. HTTP trigger functions are special in that they have an input binding that takes the HTTP request message, and they must produce an HTTP response, because that's just how HTTP works. So return value, that's the response message we created. We can say whatever we want. So this is your hello world-ish application function. One step further, because I told about the high level of abstraction, is that let's say you have a queue trigger. So some message arrives in the queue. Then you need to know where that queue is located. So in your attribute, there's some additional data there, like the connection. I've dotted it out, but it's a symbolic name that is read from your application settings. So remember local settings JSON that I referred to briefly? It's in there for your local development, and the application settings that I showed you in the portal, that's where it will be read from. And that contains the actual connection string to your queue in Azure. The queue name itself is images to analyze in this case. But inside of the queue message, there might be some information that indicates, okay, so the message is just to signify the fact that something in blob storage has appeared, and it provides the name of the blob item inside the message. So you can refer to the inside of the blob attribute that says I want to read from the blob, and its name is images / whatever was in the message. And that queue trigger with the curlies is actually the content of your queue message. So that's how easy it is. You don't have to read from the messages. There's nowhere to be seen that you're interacting with a queue or with the blob storage. Blob storage is not entirely true, because we do need to write out a stream to write to or read from the blob storage. All right. So output is a string, but it's not just a string. It's a string that should be put in a message and should be output to a queue. And that you can see it's a similar thing. You just say it's a queue with an attribute and provide a connection string and the name of the queue. So this I can just talk you through this, and we don't have to know anything about the Azure queues, but it's all there. It's underneath. It's the extensions that we saw on the web jobs. That takes care of all of this marvelous stuff. So easy programming. Yep. And there's this list, it's so small you don't even have to read it, but it's like all of these things that are there where you can interact with your functions. The triggers, the inputs, the outputs, they don't necessarily go together. But there's these things that are universal, like webhooks, HTTP, timer, but there's also specifics to Azure resources. For example, there's Cosmos DB in there, Event Grid, the Microsoft Graph we talked about, Service Bus, but there's also third-party things, and you can also write your own bindings if you wanted to. For example, if you say, okay, I have a queue, but it's RabbitMQ, well, you can write your own one, or in time, somebody will probably create one. Okay, let's drop down to Visual Studio once more. Here we go. So what I have here is a couple of things. We already saw this function, I guess. It's a function that is triggered based on an HTTP message arriving. It takes out all the headers and writes it out. So I'll skip this one in the sake of time, but we'll look at the high score function, because this has some interesting things as well. So this is a slightly more advanced still hello world as example. First of all, it's an async function, so you can write all your functions as async. And in this case, I'm indicating that there's a route to be had. Normally, if you go to your function, it will be /API / your function name, and that's your endpoint. But I can change it to whatever I want for HTTP triggers. So in this case, I'm telling it that it's high score / players and then something, and it's captured in the variable nickname, and that nickname is also here. So once we run this function, and let me put it here, we'll actually see that this nickname variable, as it comes in, is taken from the URL at which the endpoint was called. We'll read all the content here, and we'll try to parse it. If there's a score there, we'll say, okay, it's good, and you could store it in a database or whatever. Same goes if you retrieve other payloads like JSON payloads. This is where you do your stuff, right? So you take the JSON, we'll get to that by the way, and you do your thing with that. So this is all inside of a project, a serverless functions app, is what I called it. It's one of those projects that is just not a framework class library, but it's a project for Azure Functions. There's a lot of tooling underneath. And let me just start it up and you can see the tooling appear, if all goes well. So it has this nice ASCII art. It will start up all your, it will bootstrap everything. It will try to discover all the functions. So in this case, it has 4 functions that were found. And if there's HTTP functions, you can see that there's these endpoints. So if we take this one, and we go to a browser, you can actually see that there's a dump of all the headers. That's how easy it works. It works well if you have get methods, but you might have noticed that in this case, I have this thing here that restricts the verbs that it accepts to post, which kind of rules you out from using a browser to experiment with your function. But that's where you have Postman. So let me start that quickly. Let's see if we can find the right one. Okay, so here we have it. So it's in this case, it says that this is the route that we talked about with the name. This is my Xbox Live thing. There's headers here where I say, okay, we're sending some content in application /JSON, and the body itself, it's just the score that we send. And if we send the message, it arrives, the infrastructure picks it up, and it starts your function. And you see that the debugging experience is just like you're used to, so no surprises there. But if you look at the nickname, it's actually the LX360. So you don't have to read and parse URLs, for example. You can just have placeholders in there and match them up with your parameters, and will all work. iLogger, in this case, is dependency injected. It can also be trace writer. Both of those objects will be inserted, and you can use them for logging. So here we go. The logging information, by the way, appears down here. So it says the function has started and it's executing now. Let's go a bit further. There's the score. That's 1, 2, 3, 4, 5. In this case, I'm reading it from the payload, and then I just return all the values, and we should be good to go. So here it says, I think, if it's we achieved the high score, that's the output that is produced. So let's take the next one. The next one is this one. So a QR code generator. In this case, we have a bit more. The idea is that you have this part of your application, maybe some ticket is being produced for you because you ordered a ticket for a concert, and they want to give you a QR code where you can see, where you can just scan and get details or something like that. Pick your own example. In this case, so I want to put a message in the queue with the content for the QR code, and then a QR code should be generated and put into blob storage. Now you might think, okay, we talked about the abstraction, but you really don't have to know much about all these Azure SDKs to interact with the resources. The queue trigger, there's this connection that refers to my local settings file. So in my local settings, I set those all up. In this case, a special connection parameter that says use development storage. Thank you. That allows you to use the storage emulator locally. In your running production scenario, you would replace this or have the connection string to your Azure storage instead. We have this special queue that's called QR codes requests that will drop something in and will output to blob storage. But because we want a unique item into blob storage, you can use these special things, and it's all documented, but rand GUID will create a random GUID for you and put it into the name of the item that will go into blob storage. And with that said, we get a cloud blob to write to, and all we need to do is we need to have a bit of code. This is the code from a NuGet package to generate the QR code, and in the end we just write the bitmap to the stream that we opened from the blob object. But how this is connected and how it ends up in the right place in blob storage, that's all under the covers. So let's try to do this one. Let me see, we need to go to Storage Explorer. This is running locally, so I've connected it to my local storage accounts, and let's hope that they're still all there. So this is development. We have the queues, and we have here our QR code requests. We'll add a message, and I'll do the short one, fwdays 2018, like so. This will be put in here. Now it's a polling mechanism because Azure Queue Storage doesn't have any push notifications or eventing itself, so it's being polled, but if you're lucky then you don't have to wait that long. In this case, we get this image text, which is still the .NET Framework days that I just said. We generate the QR code and we just write it out, and that's it. So with a couple of lines of code, it executed, it succeeded. If we go back here and we go to our blob containers, so we have the QR code images. There should be one more, Sunday 15th. Let me see if this is the right one. It's probably the server time there. We open it up. And if you're fast and whip out your phone, you can actually test this, and this will be the code. So it's generated. Let's continue on. We talked about this. There's this SDK NuGet package, Microsoft Net SDK Functions. It does a lot of work under the covers to produce publishable output, but it puts it in an interesting place. So it's not underneath bin debug or bin release, but one deeper referring to your framework target. So that can be Net Core App 2.0, or it can be Net 4.6.1 or 4.7.1. It generates the JSON files, function JSON, which you can also find if you're doing the script style of things, because inside of the JSON file is the actual metadata, but it's generated based out of the attributes that are in your code. Which brings us to unit testing. Because during unit testing, you don't have to care about all of those attributes. So if you want to do a unit test, which I have in this project here. Let's take the dump headers. If you want to call the run method, the signature of that, it's small, but it takes the request and the trace writer. So if you create mocks for your trace writer, or you do an iLogger mock with your favorite mocking framework, then you can just prepare the request message, because those are unit testable. I mean, you can just prepare one and say that you got it from an HTTP stack. So you put some headers on there, and then you execute the function. So all the attributes all of a sudden don't care anymore, and you can just execute it. And the other one that I have is for the high score. You can test all of your scenarios. So this is where we faked it to be a post to this URL with the player name. The player name I'll provide here, and just test whatever should happen inside of the function. And it still goes that you want to get rid of all of the business logic inside of your function and remove that, or maybe dependency injected, and test that separately. But this is where you can do the minimal bit of work where you go from receiving things, checking things, and producing the output. But also the blob storage objects and all, or the queue messages. Remember the queue message that you wanted to have as an output? It was just a string. So that's how easy you can just check it, because going out, it's a string that you can assert equal. All right. So that's what I talked about, because we only have 5 minutes left. Well, let's prove that actually you can test them. So let's run them again. I made sure that they did actually work. But you know, this is the way that you can loop this into your quality gates from your CI/CD pipeline. Speaking of which, if you want to move into production, most of the Azure Functions is about Azure, hosting it in the cloud, but be aware that you can also do it on premises. It's not entirely serverless, because you will need hardware, and you will make this master machine with all these worker nodes, install the Azure Functions runtime, and you can do the same thing you're doing here, but on premises. But sometimes if you have regulations or things, it might still work for you. So the style with the scripts is where you tie into your CI/CD, based out of check-ins to your Git repo. Can be any of those things there, but we'll talk about CI/CD pipelines in VSTS. And it's actually so simple that it's, we can skim over it, because if you look at the pipeline that you need for building, this is the simplest one you can have, but it's a .NET project, and you need to get it to Azure as an app service. So what you will do is you'll get your particular version of NuGet, install it, restore the packages, build your solution from Visual Studio as it's being built on a build server, run the unit test that we just had, and then produce symbols and publish the artifacts. And those artifacts you can pick up and then just release out into Azure or any location. So you need to take care of the settings. That's particularly tricky. You can do it manually by publishing your local settings. Might not be a good thing, because you want to keep your secrets stored away safely. You can do the app settings, you can use PowerShell scripts, and you can even use ARM templates where you pre-populate the settings while you are generating the resources as infrastructure as code. But I think they will change, but you can do that with PowerShell. So there's all these values that you can have. There's key value pairs to be had, and there's connection strings, which are a separate section. So finishing up, I'll skip over that. There's more on monitoring. Things like Azure Application Insights will help you out getting the details and the metrics out. It's as simple as adding the instrumentation key into your app settings, and then all of a sudden it works, which is really good, and loops into all the other stuff that you might have in Azure. You can do the metrics thing. You can do a .NET Core 2.0. If you're interested to find out what the difference between .NET Core 2.0 and the framework 4.6.1 onwards is, it's not that big a deal, but it's more about the programming model. So you'll probably see it in HTTP request message. In .NET Core it will be called HTTP request. So small differences, but not big ones. We talked about most of these best practices, about making them small, do them one thing particularly well, almost like microservices. And one thing is that if you're doing the queue stuff, there's types of queues that you can choose. Usually you make the choice based out of the model that you have. So if you want to do publish subscribe kind of thing, then topics might be for a service bus. Or if you have larger messages, that's also a discriminator to choose your storage, your queue. So with that, 40 minutes of Azure Functions. Thank you very much. Do we have time for
Yes,
questions?
we have time for some questions if you want.
Hi, Alex.
Hi.
It was quite, I find it quite useful. We saw that we use string as incoming parameter. Is there a constraint, or can you tell us about some custom objects as in incoming parameters and custom model binding, or maybe JSON objects, or string is a constraint?
Yes, thank you. So I skipped over this part briefly,
Yep.
so I'll just cheat a little bit here.
Thank you.
So in this case, this function does an import, but it can be anything. But the idea is that you put some JSON into a message and get that to a queue, and you read from the queue. But if you look at, in this case, I'm not expecting a string, but I'm expecting an array of high score items. So I created this model, which is just, you know, these things, game, nickname, score, which is able to read something like this. So if you're asking about how do I transition from JSON to objects, you don't have to do it yourself. You just say, okay, deserialize it into this array of something, or just a single object. If it's parsable and it can be deserialized, you will be given the object of your choice.
So no custom binders.
Sorry, so no?
I can't use my own binder. I can't use my own binder. Only the default.
Okay, so the question is, can I use my own binder? Yes, you can. There are custom bindings. I'm not entirely sure if you want to do something other than XML or JSON, but if you can build your own bindings, and you can even, without specifying them as attributes, you can do runtime bindings that you hook on in runtime. That's possible.
Thanks a lot.
Yeah.
Hi. Could you talk?
Oh yeah, sorry. The lights.
Could you talk more about limitations? I know that there were limitations like 1 CPU and 1.5 gigabyte per function and 10 minutes.
Mm-hmm.
Are they still? If I want to run some calculations that consumes 10 gigabytes, it's possible or not with consumption plan of Azure Functions?
Yes. So what I didn't mention is there's the consumption plan where you just pay for what you use and it goes to zero.
Yeah.
That's the one where you can have a certain amount of compute. That is still available. So the restrictions are evolving. You can increase the 10-minute limit on your function executing to something bigger. But my question would be, if you want to leverage functions, you would do the scaling part, right? So you can have one single function instance that is very big, but if you can apply maybe MapReduce or other things of splitting it out, that would be ideal. Because that's where you can just fan out, do multiple parallelism, and then loop it back together again. And one of the things that might be of interest there, if you can find ways of doing it, is durable functions, because they have the fan out, fan in scenario, for example. Durable functions is on top of Azure Functions and allows you to do long-lasting processes with multiple steps or these other scenarios.
But limitations with 1.5 gigabytes memory for one Azure Functions run are still there?
I can look into that for you. I don't have the numbers on the exact hardware limits top of my head, but if you give me your details, I can certainly look into that. Yeah. There's two people there that were up long. Oh.
Hi, Alex. As I understand, we treat Azure Function as a computation unit. But in your examples, I saw a lot of code with async await stuff. So if that makes sense to use asynchronous with Azure Function if we need to calculate something. Async await, for example, if we refer to Web API, we used to release to thread pool to process another request. But if Azure Function as a computation unit, why we need this stuff? Should we release some resources to process another request? Because as I understand, one request, one Azure Function, one instance, and that's all.
Okay, so underneath the covers, I think there lies the answer. It's IaaS running all the things. IaaS traditionally still has all the thread pools, and you want to work efficiently with the pools that are there to not exhaust your request worker threads versus your other worker threads. If you do the async await, that pays off essentially, especially well if you're doing the external resources thing that have I/O in some form, so to memory, to disk or a network. So that's where async await comes in. So if you only do async await for a normal compute, it doesn't benefit much, but I think that goes for every scenario. So the async await is usually because the modern APIs sometimes only have async await, and that's where you have your function. So it's not essentially about playing the thread pool game. I wouldn't recommend doing your own threading models, but it's just using the API and being a good sport amongst, you're sharing anyway because you're in a co-hosted environment on Azure. Does that answer your question to some extent? We can talk afterwards and have a discussion. That's good.